This is going to be a full detailed build of a Hovership Zuul Racehound. This is a 265 version for 5-inch propellers. I'm just checking all the carbon, making sure I have all the pieces that I'm going to need, laying them out, inspecting them. Everything looks good. So stack it back up for safekeeping. Next up is the motors. So I'll unbox those. These are the Lumenier 2206 2350 kV motors. I really like these motors on my 6-inch, so I'm going to try them out on 5-inch. They make really good power on 6-inch. I'm hoping, and they're also really smooth, so I'm hoping they'll do well on 5-inch. They come with a low profile an aluminum nylock nut, which is a nice touch, lightweight, and works pretty well. For speed controls, I'm going with DYS XM20 ESCs for this build. These are, I guess, the latest Scilabs chip, the F39X. I don't know what the last number is, but they're lightweight, they make good power, and they're easy to work with. FPV camera is going to be the Foxeer HS1177. This is probably the most popular FPV cam right now. It's easy to mount, it's compact, it's got a case. You can interchange the lens for better lenses or wider lenses or whatever you want. I'm probably going to swap that out for a wider lens. Flight controller is a Motolab Cyclone, which is basically an upgraded Tornado. It's nice because it's got a flat bottom, and the gyro component is connected with a faster bus, so you should get faster loop times with it. PDB is going to be the Matec. I really like this guy because it's got two regulators, 5-volt and 12-volt, built in. It's small, low profile, and it's also got a flat bottom, so you get a nice tight build with it. Video transmitter is going to be the Aomway 200 milliwatt. I really like these. It's a similar form factor to the Hawkeye. It might be the same as the Hawkeye. It's got the SMA soldered directly. Good for how I'm going to build this because I have this antenna, the Triumph, which is nice. It's got an RP SMA connector, so you have to make sure you put this adapter on if you're using something like the Aomway. Make sure your connectors line up right because that's really important. You don't want to use the wrong connector and have it not actually connect and burn out your VTX. This antenna is great because it bends and it stays where you bend it. So I'm going to take advantage of that and kind of mount it low profile on my top plate. And of course, LEDs. No racing drone would be complete without some cool looking LEDs. And we have our 13mm Hovership spacer. These are printed by Hovership, and they do a good job of putting everything where it needs to be and keeping the build tight. So the first step I like to do is prep the motor screws with Loctite. This is a really important step. Most people, or I don't know, some people don't do this. I definitely do this with every ship that I build because on my first Zuul, I neglected to do this. I thought I had the motor screws on super tight, and I took off probably about by the third pack. I was 50 feet in the air and just came tumbling down to the ground. And I found it, and one of the motors was just dangling off, and that's pretty much all that happened. I put the motor back on, it flew fine, luckily. Broke a few props, of course, but after that it was fine. So ever since then I've been Loctiting all of my motor screws. I usually put some Loctite on other screws as well, just depending if I notice they get loose, but especially the motor screws for sure. So what I like to do is just line up the carbon parts, how they're going to be on the final build. That way I know I don't put a motor on the wrong side. And then it's just as simple as lining up all of the motor screws, getting them threaded in, and then getting them tightened up. Again, you have Loctite on here, but you really want to just go ahead and get a good torque on these guys. I mean, I'm sure you don't want to over torque it, but you don't want them to be loose at all. And the other important part is to make sure you're using screws that are the appropriate length, because if you use screws that are too long, what will happen is the screws will actually go into the motor windings and short the motor to the carbon frame. So I'm checking here to make sure that the screws are the proper length, and these screws are right. My My motor wires are a good length, so I'm happy. I'm just going to zoom through the rest of these and not really care because they should all be the same. I think the screws that I'm using here are the ones that actually come with the motors. They're perfect for 3mm arms. So if you have arms that are bigger than 3mm, you probably want to source a little bit longer screw. I think 6mm is probably what you want for a 4mm arm. I could be wrong. Could be 6 is good for 3, but you'll need to just double check. If the motors that come with your, or the screws that come with your motors are too short, then you'll need to upgrade them. So here I'm just test fitting, just making sure that the wire is going to be long enough to reach the ESCs where I want to mount the ESCs, and making sure that everything's going to be good how it is so I don't have to get any extra wire. Now is where I really start the main part of the build. I'm going to line up these holes. Normally you put them in front for a Super Beast, but I'm putting them in back on a Racehound here because I don't need to mount a GoPro cage. So if I put them in back, then I can route my LED wires out those holes. What I like to do with the PDB is insulate it with some electrical tape so I can get it flush or mount pretty flush to the bottom plate. I don't like to leave a lot of space because I only have 13 mil to work with, and I want to be able to fit a USB cable in to interface with the flight controller. So it's important that I stay as low as possible. I just punch out some holes, make sure the tape's lined up, and the screws are going to go through the holes there, so it should be good. I just trim the tape off, and once the tape is all trim, then I can start mounting the PDB. I'm not sure how critical it is to tape the bottom of the PDB, but I definitely don't want to take any chances shorting something, and it's a pretty simple step. Doesn't really add any weight, doesn't add much time or height to my stack, my final build. So let's make sure I insulate it somewhat. I'm going to put some screws through and these nylon standoffs for the flight controller. Basically just line up the PDB, pop the screws in. Now because I put tape there, there's going to be some resistance, which is good because I can screw them in and the PDB will hold them. The screws won't just fall out, which makes it a lot easier. I'll put the standoffs on. I like to put the standoffs on now because the way the pads are on this PDB, they get a little close to the standoffs, so I know exactly how much I can tin the pads with solder without actually going into the space of the standoff. It doesn't really touch the standoff, but when I use the hex standoffs, the little corner of them might be difficult to get around if I put too much solder on. Now I'm just test fitting the height. Everything looks good. Looks like it's going to be exactly where I need it to be, but just in case, I'll put the spacers on, put the top plate on, and take a look. So you can see here that it's pretty good spacing. I should be able to clear that USB and plug in a USB cable while everything's connected. Finally, get to some soldering. I like to use the Hako electric soldering here. It's really good. I tend to solder hot, 750. You can lower it if you want. I like to solder hot and fast. I think you get less heat transfer into your components. If you solder really hot, if you turn it down, you have to leave the solder tip on your components a little bit longer, and that this leads to, I think, a little bit more heat transfer. So the main thing when you're soldering is you want to transfer as little heat as possible into the surrounding components of what you're soldering. You want the heat to get into what you want the solder to stick to, but not much farther than that. Especially when you're soldering ESCs, it gets really delicate. The XM20s are really good because they have a pad that's a little bit farther away from the FETs, so it's a little bit easier to solder those. You don't have to worry too much about overheating them, but in general, you don't want to overheat components when you solder them. So now I'm just tinning up this board, making sure the connections I'm going to use have a good amount of solder so that when I do make the final connection, it'll be really quick and I'll make a good connection. Notice I'm not using the 5-volt regulator because the flight controller has a built-in 5-volt regulator. Now for the ESCs, I'm just going to tin them. You see the pads are separated out here, It makes it a lot easier. You don't have to, usually with other ESCs, you'll have to take them apart and desolder the wires that they put on there in the factory. Usually pull off with solder wick the old lead-free solder they use to solder those wires on. But these are easy because they come bare. Makes my life a lot easier if I can solder properly. Just tin up all of these pads, which is done in no time. Really, this saves so much time compared to how ESCs used to be. It's really important to clean off your soldering tip. Some people, like NASA types, will do it every single solder joint. I don't think it's that important on these builds, but a good tip will transfer heat faster, and fast heat is a better solder joint. I love the 3M VHB, the black VHB tape. It's really good. Stick it on and press it on and then let it cure overnight, and those things aren't going anywhere. So prep all the ESCs with tape. Get my scissors all sticky so they barely cut. And now I'm just going to test fit this spacer on, just temporarily with some screws, just so I know that I'm not mounting the ESCs in a bad position for a screw or too close to where a spacer would be. So basically just putting the spacer on. And then I can also mount the arms to this spacer temporarily, so I can make sure that my motor wires are the correct length and the correct spot, and when I solder it, the wires will be the perfect length. I like to get everything as exact as possible, so I will mount the ESCs right there and then trim the wires. I forgot to mention the receiver I'll be using. I pulled this off an old build. I didn't have a brand new one laying around. This is a FreeSky X4R SB for S-Bus, and I've already depinned it and soldered a new pigtail to it, so that's why it looks like that. I just put some heat shrink on it and cut out the hole for the LED and the bind button. So first thing is I'm going to mount this and make sure that my pigtail lines up with the pins on the flight controller, the S-Bus pins on the flight controller. Lucky for me, the S-Bus pins are right there in the back, so if I put the receiver right there, they just line up perfectly, and it's no big deal. For the ESCs, what I like to do is go ahead and put them in the final spot they're going to be in. I like to trim the wires exactly to the correct length and not have any slack. So I will tape them down, make sure that they're going to fit exactly where I want them, and double check that the motor wires are going to fit. And then I can go ahead and start trimming the wires so that they can be just exactly as long as they need to be. Trick with this tape is to make sure you don't get too much oil on it from your skin, from your fingers. Don't get too much dirt on it. If you get a good connection with it on clean surfaces, it'll hold through pretty much anything. Now that I've got all the ESCs mounted, I want to check the motors. Motor wires look good. Looks like it's a good spot. And in the meantime, I will prep for the main power lead. I like to solder this one on first because it's usually the biggest cable, and if you put the smaller ESC wires onto the PDB first, then you don't know if you have exactly enough room for the main power lead. So I like to solder the bigger wires first, make sure I have room for them, and then it's easy to fit the smaller power leads in after that. I'm just tinning the tips of these. Just stripped them back, tin the tips. I've already tinned the PDB, so I'm going to get a little bit of solder onto the tip of my iron and then bridge that molten solder onto the tinned pad and tinned end of that wire, and they should both melt pretty quickly, and that helps. If you can get a good molten if you can get a good melted solder pool at the end of your soldering iron, then that really transfers heat faster into the solder joint. Basically what you want to try to do is just get that liquid touching the pre-tinned ends, and they'll melt almost instantly, so you get a lot less heat going into the wire and going into the board. The wire is not as important, but the more heat you get into the wire, the more solder will get sucked up into the jacket. So you don't really want to do that, because the wire will become really stiff. So now that I've got the power leads on, I am just getting the ESC power leads lined up. Same solder technique here, just a little bit smaller. I like to strip the wires with my fingernails because the silicone is pretty soft and easy to strip back. Don't have to worry about getting out a new tool, and I get a better feel for it if I do it with my fingernails. So this goes pretty quick. Once this side is done, then I'll move on to the next side just after inspecting. The only issue here is with these nylon standoffs, the PDB does get a little close to it, so just I gotta make sure that the iron doesn't get too close to those standoffs, otherwise it could melt the plastic, and especially don't want to melt the threads. So front end is done. Now for the back two ESCs, same procedure. This time I'm going to have a smaller power lead for my LEDs. So I'm going to do the same procedure there and solder this one to the middle. Once that's good, then I will do the same for the remaining ESCs. You definitely can't be afraid to cut the wires as short as they need to be. I know it takes practice and a little bit of experience, but as long as you measure it well, you can be pretty confident in your cuts. And if it's too short, then you can always deal with it. You can always desolder the ESC end and just put a new wire. Usually the piece that you cut off will be more than long enough to replace what you need, so it's not really that big of a deal. And if you do that a couple times, it'll kind of teach you exactly where you need to be. You'll learn from your mistakes. So you can see here, or you can see there, that really what you want to do is get all of the solder melted on the pad, on the wire. Make sure it all melts together so that it all cools together. Now that those are set, I need to get the final screws in for the spacer. I'm using, I think these are 23mm screws. Sounds right. Actually, they're probably a little bit smaller. Basically, I'm just going to thread them through, get them sticking out the other end so I can put the arms on, and I will secure the arms with the spacer so I can solder on the motor wires. Just put a nut right there and tighten it down just a little bit so the arm doesn't move too much. Get the other one on. It doesn't need to be all the way down, just enough to hold it in place so it's pretty much in the right spot. It's going to be a little bit more slack on the motor wires than on the ESC power wires, so I don't really mind if it's not perfect, because I'm going to zip tie everything and then zip tie it to a slot in the arm, so I'll take up all the slack when I zip tie it. This part is a little bit more tedious because you're putting the nuts on and you're getting the arms mounted, but then you have to take the nuts off later when you actually put the top plate over it. I think it's worth it because you end up with a nice clean build and your wires are definitely the perfect length. Notice I didn't cut the power wire. The main power lead, I didn't really want to guess, and since I didn't want to waste all that cable by cutting it too long but not long enough, I just left the whole piece on there. Just want to get the ESC signal wires out of the way. There's a lot of wires. They all haven't been trimmed yet, and those won't get trimmed until the flight controller's on, so just roll them up and tape them out. Same thing with the LED power lead, get that out of the way. Because each motor is going to have 3 wires, so you just end up having to deal with a lot of wires. So the more you can kind of get out of your way, the easier it is to work. Plus on this back end of the ship, I'm going to be routing the antenna wires through with the motor wires out the back of the arm. So the cleaner my workspace is, the better. So what I like to do is just put a little heat shrink over the motor wires, and then I can slide the antenna through that heat shrink, and that's enough to secure it. Shrink that down a little bit. Make sure it's going to hold, make sure that the wire is in the right place. Looks good. Same thing for the other side. And then these ESCs are already heat shrinked, but the tab or the solder tab ends aren't. So I'm going to put a little bit of heat shrink over these wires. So after I solder them, I can just slide those up and just cover that exposed piece. I don't like to leave it uncovered just in case a blade of grass or something makes its way in there and somehow bridges it. And even though blades of grass have a lot of resistance, there's still water in them, and I don't, that's something that you don't really want to have to deal with. And a little bit of heat shrink or tape or even liquid electrical tape or conformal coating over the ESC solder tabs will prevent that from happening. So I don't really care what order these are in. I'm kind of just soldering them based on how their length is. I kind of cut them 1, 2, 3. They get mixed up because the way I routed them. So I don't know which one, which order they're going to go in. What I do is I just solder however it goes, and then I'll check the motor directions once everything's done, and I'll fix it in the software. So if one motor's spinning the wrong way or 4 motors are spinning the wrong way, it doesn't really matter because I can just go into the ESC software and hit reverse, and that's no big deal. Now that I've got these soldered up, like I said, I'm going to put them all in the zip tie in this arm slot, take up all the slack, and keep it clean. It's important to keep the motor wires clean because if they get too loose, then you could easily get one going into a propeller. They sit right under the propellers, so you get a little bit of damage in your propeller, or the wire gets pinched in a crash or something and it pulls out a little bit, then you could end up severing the wires, and that's a pain. I don't like doing those kind of repairs, and I really don't do field repairs, so for me that would be a go home, or at least put the ship away and take out the spare. Front of the ship gets kind of the same treatment. Don't have to worry about the antenna wires, and it's a little bit more space, so it's not that big a deal. It's a little bit easier to work on this side. Should go pretty quickly. Again, I'm just trimming. I don't really care about the order. I'm just trimming them and just soldering them in the order of the way I cut them. It makes it a whole lot easier to have some tweezers or some needle nose pliers when you solder. Definitely don't want to do it where your fingers are right there because it gets really hot, and then on the other hand, you can't really see that well, and your solder joints are going to be better if you can see everything melting. And the other thing is, you really don't want to move that solder joint until it cools completely. So if you're holding it with needle nose pliers, it doesn't matter how much heat builds up, you're not going to want to pull away from it. If you're holding it with your fingers, you'll be more likely to pull away from the solder joint before it's completely cooled. So what I do here is I solder, and then I let the needle nose pliers sit there for a little bit. Once it's completely cooled, I pull away, and the solder joint doesn't move. It gives you a much better solder joint, much more solid connection. Now that I have the ESCs all wired in, well, actually all the power cables for the ESCs all wired in. It's time to get started on the flight controller. The first thing I'm going to do is get the power lead ready for the flight controller. I'm lucky because I'm using the Motolab Cyclone here. So really all I need to do is just pull off battery voltage and connect it to the voltage in pins on the flight controller. I don't have to worry about any regulators. I don't have to worry about stepping down to 5 volts. I can just give it straight battery voltage and it'll take care of the rest. So I just need one cable here, or one wire here, and those are going to go to these pins. So I'm just making sure that the length is going to be good. At this point, I'm also going to get the receiver soldered in. My pigtail is a little bit backwards here, so I'm going to have to flip it over, but that's not that big of a deal. Just going to get these ready, pre-tinned. Just get a little bit of solder on there so that the wires don't come apart when I put them in the through hole. And I've got the signal on the correct side. Make sure they line up correctly in the pins. The difficult part about this board is that it's not really labeled, so you need to go back and refer to diagrams, make sure you're soldering everything in the right spot. So that looks pretty solid, and it looks like it fits nicely. Once that's done, I can trim the power lead for the board to length, strip it back, tin the wires, and repeat. It's pretty critical that you get the right wire length when you're doing a build like this, because all the wires are going to be tucked in between the flight controller and the PDB, and you really don't want to put a lot of pressure on those components that are on the PDB. So the shorter the wires, the cleaner they go into the through holes without having solder wick down into the jacket and making that wire longer, or making the stiff part of that wire longer. The shorter you can get it, the better. The more compact your build will be. And I also like to solder a buzzer lead, because I don't always like to rely on my ESC motor beacons if I lose my quad, and I don't actually use telemetry. I go off a timer, and it helps to have a buzzer to kind of just give me a sanity check. If my battery voltage drops too low, I can set the flight control software to start setting the buzzer, so I know that, hey, maybe I should land and check the battery. That way I don't ruin any batteries. So it's pretty simple, and I can just tape it right there and just kind of forget about it. The only things on this back side of the board are the receiver, the power, and the buzzer. So I'm getting those taken care of first. Once those are done, then I'll move on to the ESC signal wires. Everything looks clean here. The buzzer's all tucked in. You can see everything's soldered nicely on this side. Now it's time to move on to the other side. Get those done, and it looks like I have good clearance on everything, so this should go pretty easily. These are some of the scariest ones to cut to length, because you definitely don't want to stress these wires. It's very critical. The signal, the electrical impulses that are coming over these wires are very critical. They're basically telling your ESCs at thousands of times per millisecond what to do. So you want to make sure that these are solid. You want to make sure that nothing gets pinched or rubbed or squeezed the wrong way. I think this wire is a little bit long here, but I'll be okay with it. It'll be alright. I can just kind of push it over to the side. So make sure the rest of them are good. Make sure they don't bunch up too much, and you definitely don't want to pinch anything. Same procedure, just kind of tin the wires so that all those excess strands don't kind of get pushed back when you put it through the through hole, because you really don't want to short it. You definitely don't want to short it. I do like direct soldering a lot more than the pins. It allows for a much tighter build, allows for more solid connection. I know that it's a lot easier to maintain when you don't direct solder, when you can just pull the pins, but I've had it before where after hundreds of flights and dozens of crashes, those little servo connectors get a little bit loose, or if you don't pay attention the wrong day, you could be over something, over some concrete, or over a tree, or over some water. And if if one of your motors cuts out, or one of those connectors comes loose and drops a motor, you're going to fall out of the sky. So I'd like having a more reliable direct solder connection. I'm going to trim these up. I just like to have a little bit of slack so I can pull that solder heat in really easily. It's a little bit of extra wire underneath, but it'll be okay. Now I'm getting ready for the video transmitter power lead. I think this is the last thing that's going to go on the PDB. This is pretty simple. I give it 12 volts because the ESCs can actually spike and give a little bit more voltage than battery voltage. So instead of putting another capacitor in and trying to absorb that spike, I like to just put it on a regulator. That way my video transmitter doesn't get blown out. And I'll run the rest of my electronics off of the video transmitter's 5-volt output. I'll run my FPV Cam and my GoPro power lead off of that, so it's not really a big deal to me to have anything else step down because it all goes through the video transmitter. Now I'm just getting a power harness ready for my LEDs. I'm going to go overboard with the LEDs here because I want this thing to be really bright. I want people to be able to see me when I'm in front of them, beating them in races, so I like to have a lot of LEDs. This is a pretty simple harness. I just got a lot of space on this wire, make good contact, flow a good amount of solder in just to make sure that it doesn't crack over time. Just want to make sure you get heat all the way through this solder joint. The more heat, the better the solder melts and the more solid your connection will be. And of course, you don't want that solder joint to move before it's cooled down. I like to just heat it up and feed some solder in and let it cool on its own. So those look good. Heat shrink them up. And now I'm going to route the wires where they need to be. This can be kind of a pain, but if you take your time and you measured right to begin with, then your wires should land right where you want them. And I'm going to need obviously one voltage and one negative at each spot. And I'm putting 2 on the bottom and 2 on the back on each side. So there's a little hole here in the spacer where I can thread the wires through. And there's those 2 holes for the Super Beast cage that are normally up front that I moved to the back that I can use for the bottom LEDs. So it looks pretty good, and it looks like that harness is the perfect length, so I'm really happy with that. Now I can go ahead and start buttoning up the whole bottom plate, put this top piece on. It's just a little cosmetic cover. I'm going to trim this screw because they're kind of long and they're just nylon, so it's no big deal. I think I'm going to end up taking one of these screws out because it's going to interfere with the buzzer, but I don't know that yet. Aluminum standoffs for the very top plate. Make sure these are good and tight because if they come loose, it's going to be near impossible to tighten them without taking anything apart. And I like to use this center screw for the FPV Cam. I didn't want to file out the slot, so I just used 2 of the smaller screws that come with it. Before I button everything up, I'm going to get these LEDs installed just in case there's an issue with my harness or something's not right. I think it's easier. These LEDs are pretty easy to work with. Basically, there's some solder pads here, so I'm just tinning these up, and you could actually run these, I think, in series, but I find it easier just to run cables exactly where I want to go. I have to worry about polarities or how that's going to work. So it's pretty simple. I mean, it doesn't really get much easier than this. The solder pads make it super easy. I'm giving it straight battery voltage, so I'm not really worried. I'm gonna tape down the final destination for these so I can trim these wires to be the perfect length. The other LEDs, I have a little bit of wiggle room where I'm going to mount them on the back, so I didn't really care about how perfect those wire lengths were. These are looking good. I like the placement of these. And that solder is complete. Now I'm going to use some clear heat shrink. This will protect the LEDs and prevent any, since these are going to be out, on the bottom of the ship. If I crash on some wet grass or something, there's really going to be little chance of shorting that lead. And like I said, it goes straight to battery, so definitely don't want to short it. Shrink these up. You'll still be able to, the heat shrink's not completely clear. It's a little bit opaque, but you'll be able to see the LEDs fine through it. This is a little cosmetic thing I like to do on the top plate. There's a cutout with the Zuul writing, and I just like to put a little bit of orange paper behind it so it shows up when you see it at a distance. I think it looks a lot better. It really is minimal weight, maybe a gram or two, if anything, and it looks a lot better. Let's get some clear packing tape and just make sure that's solid on there. Trim as much as possible. You want to make a good connection, but obviously you don't want to use too much or have it overlapping on the open holes because it'll just collect dirt and peel away. Next up is the video transmitter and antenna, obviously. I use VHB to mount it. I really haven't had any problems, and anytime I've had to take a video transmitter off, it's always been a pain, so the black VHB holds it really well. I'm going to try to tuck this pretty flush right here, so that's a good spot. And it's I like the way these antennas bend. Keeps it low profile, and they really hold their bend well. I'll probably zip tie that to keep it a little bit more secure, but for now it looks good. You can see I've changed out the lens on the FPV camera. I like a wider lens. Lets me see a lot more. Gives me a little bit more latitude on how much camera angle I have to run or how little camera angle I have to run if I want to still fly slow. That's pretty much it for the bottom plate. Last couple of pieces, and I'll thread the power lead through the top plate here. I already put a battery strap in. I just need to line up all these screws, and these standoffs are the first thing I tighten down because it's going to take a little bit to get all the nuts on these arm screws and get them tightened down nicely. You can actually, there's 3 holes. I don't know if you can see it. You can see it there. There's 3 holes. The other hole, if you move that screw to the other hole, you can actually fold the arms. I don't really like to do that unless I'm traveling. I'll just move that screw when it's time to travel and fold them. So in normal operation, I like to keep it just completely locked. This is this little 3D print GoPro wedge I have. Hovership actually makes a really nice new design. I didn't actually have one to spare when I was building this. Still in prototype phase, but this will work. And I just want to line up the GoPro because what I do is I have a USB lead that connects to the 5-volt in the video transmitter, and I just want to make sure that that 5-volt lead is going to be the correct length. So I'll mount the GoPro now, and when I solder in the 5-volt lead to my video transmitter harness, I'll make sure that it's the perfect length. The last thing I want to do is have that wire be too long and then get kind of in the way of the propellers or get caught in a tree branch or something. So basically I just need to measure all the wires. I'm going to connect the camera to the video transmitter, 5-volt out, ground, and video. I'm going to clip away the audio wires on the video transmitter, and then I'm going to solder 5-volt and ground to the GoPro lead and the camera, and then I'm going to solder just the video signal, or the video signal to the camera only, obviously not to the GoPro. I had to put a little bit of heat shrink there because the ground wire on this harness that comes with the Aomway VTX is actually the shielding for the wire. So since I exposed it, I just wanted to make sure I covered it up. This is going to be pretty much the same concept as what I did earlier, but these wires are a lot thinner and a lot smaller, so they're going to be a lot more fragile. And these are pretty critical. The LEDs aren't critical, so if something goes wrong with that solder joint, I don't really care. But obviously, these need to be completely bulletproof. If you have any one of these wires go bad in flight, you're going to have a really bad day. So just take your time, make sure that everything's connected well, pull on the solder joint, let it cool, make sure it's shiny, and shrink it up really nice. I like the way that turned out. It's pretty compact. It looks nice and clean. The USB lead is a perfect length. The camera lead is short, but not too short. So I like that. The video transmitter lead is a little bit shorter than I wanted, but it's not a big deal. It'll still work. That's pretty much the main parts. I'm going to get this top plate bolted in. And really all I have left is the main power lead. So I'm going to continue zip tying all of this, and now it's time to finally get this XT60 soldered on. It's pretty much the last component, or last major component. Obviously I still need to put the propellers and go over it and do some final touches. And I also need to configure all the software, the ESC software, the flight controller software. That's going to have to be for another video. I'm not going to go through that here. I'm basically just going through the physical parts of the build. Definitely, if you guys want, I will go through it and do a tutorial for all the electronic stuff, or all the software pieces. So XT60 is good to go. I think I'm going to route that here and zip tie it. I like to zip tie the XT60 because I hate when my power leads go off in weird places. This is a current limiter, just an automotive light bulb soldered in line with the voltage cable. It'll light up if there's a short instead of the short taking over my electronics, and it's not lighting up, so it looks like I'm good to go. And the LEDs are really bright. This is exactly what you want to see. Now that I've got that confirmed, I'm going to throw some propellers on. I like these Gemfan 5050 bullnose tri-blades. These are my favorite propeller right now. I'm going to put these on, and I will give it a little test hover. It's just a kind of operational check, make sure that all the motors spin, under load, and that the flight controller can do its job and stabilize flight. I also want to test my battery here, make sure that I can strap it in properly, that I can kind of tuck the lead away. So if I twist the lead like this and plug it in that area, it's clear of the propellers. And all that's left to do is see if it'll fly.
Just how I do. About that door, huh? Go install it.
Awesome. Thanks for watching. Please like and subscribe.